Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic, angles and plane figures. And for this particular lesson, we want to discuss about triangles and angle properties involving triangles. Part A. We'll be having part B during our next lesson, but this we're going to cover part A of this concept. So we want to see how triangles can be involved in angle properties. We want to look at majorly types of triangles and the angle properties involving these respective types of triangles. And then, of course, at the end of the lesson, we'll be able to give you some assignment just to help you with practicing and just to help you gauge on your understanding of the concept as you're going to discuss during this lesson. So this is what we call a triangle, ABC, that shape. See, it is actually, it's called a polygon, one of the polygons, those figures that are bounded. So for triangle, is normally bounded by three sides. See, there is this side here, there is this side, there is that side, and there is this side. That's a triangle, a three-sided figure actually. We say a triangle is a three-sided plane figure. So the angle properties involving this is that sum of interior angles, the sum of the three interior angles of the triangle add up to 180 degrees. That's how we write degrees. Superscript. Small zero up there. So the sum of three interior angles so we have this. Maybe let me highlight in a different color so that you see what's happening here. So we have this one here, we have this, and we have that. So if you call this Z, you simply say that, or let me call it a different letter. You call it maybe something like what? Maybe M. So you'll say then X plus Y plus M should be equal to 180 degrees. Later on, we might be talking about exterior angles of triangles. For now, I'm just mentioning sum of interior angles of a particular triangle, summing up to 180 degrees. Okay? So you take this one here, you add to that, should be giving you 180 degrees. So we have triangles, different classifications of triangles, or different types, or triangles can be named differently depending on certain characteristics they have. So we say triangles are classified on the basis of either angles or sides. So you could find triangles that are having all the sides being the same, equal in size, all the interior angles being equal in size, or two interior angles, So that can be a basis of naming that particular triangle in a particular way, you see. Yes. So for example, when we have a triangle in which one of the angles is 90 degrees, we call it right angled triangle. And a very good example is this. Previously, I talked about this symbol. This symbol here, you draw a triangle and then you label that box. Let me just draw one here so that you see. So we have something like this. This is a very good example. And then you have that. So, and then you just draw this box here. This shows that this angle, it is the symbol that we use to mean 90 degrees. So if you don't indicate 90 degrees, you just use that symbol there. See? So if this is triangle A, B, C, this triangle is called a right angle triangle. Every time you have one of the interior angles being 90 degrees, the triangle is called a right angled triangle. Just as simple as that. You don't have to struggle to get to understand what a right angle triangle is. Just check whether one of the interior angles is 90 degrees, then you just conclude straight away that is a right angle triangle. So we'll be using that term a lot as we continue with our career in mathematics. Remember, this is just mathematics book 1. This is just mathematics form 1. We'll be going to mathematics form 2, mathematics form 3, mathematics form 4, and after that, university. you'll still be using this term right angle triangle. So every time this word right angle triangle is used, then you know that is a triangle with one of the interior angles being 90 degrees. So you see, a good example is there. I've also drawn another one that is nicely drawn in blue color there. You can check. We have this one also. This one now. This one is a triangle in which all the sides and interior angles are not equal. They are all different. Okay. So this side here, there is also this side, and there is also this side here down here. So all those sides are different, and even the interior angles are different. Remember, we said that some of interior angles a triangle add up to 180 degrees. See, so this one is 55 degrees. Yeah. So we can be able to find this M here. So let's try and find M. So for us to find M should be, or let me write it this way. Say that 70 degrees plus 55 degrees plus M should be 180 degrees. So if you add this plus this, it should be 125 plus M should be 180 degrees. So 125 can move to the other side. So M should be equal to 180 degrees minus 125 degrees. So what do you get? So that is going to be 55 degrees. So let me change this to 45. So we'll have to change this to something else. So this one here is 45 degrees, 45. So that so if you add this to 45, so if you add this to 45, we'll end up with 115. And so we take 115 to the other side. And so what do we end up with? 65 degrees. So M is 65. So this is 65 degrees. So when you have this one here as 45 and this one here as 65 and the other one is 70. Now you can see all the interior angles are different. So you say a triangle in which all the sides and angles are not equal. They must be different. They're not equal, they're different. So such a triangle is the one we are calling a scalene triangle. This is 45, the other one is 65, and this one is 70. See. See. So that is what we are calling scalene. We have another one here called isosceles triangle. So let me complete it. Okay. So if you call this one X, let me call that X. You've said sum of interior angles should be 180 degrees. So you have X plus 20 plus 140 degrees should be equal to 180 degrees. So x plus 160 should be equal to 180 degrees, and x should be equal to 180 degrees minus 160 degrees. What do you get? 20 degrees. So this one here is 20. So this one is what we call isosceles. These angles that are the same here, we call them base angles. You know, they're called base angles. So one of the properties talk about base angles of an isosceles triangle are equal, and also these sides are supposed to be equal. You know, this side, this one, and this are equal in length. The moment you have the angles, this and that being equal in size, it also means that the sides here and that side are equal. Again, when you have this side and this side being equal, then also the angles must be the same. So sometimes we'll give you the sides being equal, then from there you can conclude that the angles are the same. If you give you the angles being the same, then it will also conclude that the sides there are also equal. There is what you call equilateral triangle. So equilateral triangle is one in which all the sides are equal and all the interior angles are also equal. Just try and find this one. Maybe I can call it y. So I have 60 plus 60 plus y is equals to 180 degrees. So 120 plus y, 180 degrees. So y is equals to 180 degrees minus 120 degrees, and that is 60 degrees. So you can see this is 60 degrees. So all of them are the same. That one is called an equilateral triangle. Equilateral triangle. That is the name we are giving to such. Again, if you realize that all the interior angles are the same, then it implies that all the sides are the same. So this side, so this so this equals to this. Again, if you have all the sides being the same, then it also means that all the interior angles are the same. So that is a conclusion that you have to make, you know. And so that marks the end. We have a few questions to help you practice on what you have been learning through this lesson. Otherwise, that is all for this lesson. Until next time, goodbye.